Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular paper is June 2019, paper 1, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA GCSE Maths past paper walkthrough. This one is from the June 2019 series, although you can see here it's actually dated from the 21st of May. We're doing a higher tier today, and this is paper 1. Question 1. Here are 2 right-angled triangles. Circle the value of y. Now you'll notice these 2 triangles both have an x angle here, so these angles are equal. They both have a right angle here, so these angles are equal. And because the 3 angles of a triangle add up to 180, then these 2 angles must also be equal to each other. So basically we've got 2 similar triangles here. So with similar triangles you can find pairs of sides that match up. So this one matches with this one, and this one matches with this one, and sides should be in the same ratio. So we can work out what the ratio is from one side to the other. So from here to here, look, we've gone from 10 to 15, so that's a scale factor of 1.5, isn't it? So 15 is 1.5 lots of 10. So taking my 6 then and multiplying it by 1.5, I'm going to get 6 plus half of 6, which is 9 then, isn't it? So 9 is the value of y. Question 2. Work out the value of 1 2/3 raised to the power of 2. Okay, I'm going to rewrite this first. I'm going to rewrite it as a top-heavy fraction. So 1 2/3, 1 times 3 is 3 plus 2 is 5. It's 5/3. 5/3 raised to the power of 2. Now, when you've got an index of 2 things inside of a bracket, either multiplied or divided together, you can apply that index to both numbers separately. So here it's the same thing as squaring 5 and squaring 3. So 5 squared is going to give me 25, and 3 squared is going to give me 9, which if I then turn that back into a mixed number, 9 is going to 25 twice, remainder 7, so that's 2 7/9. So that is my answer there. Question 3. Work out the arc length in meters of a semicircle of radius 6 meters. Circle your answer. Okay, work out the arc length in meters of a semicircle of radius 6 centimeters. Okay, so if I've got a circle and I cut it in half, then I've got 2 semicircles, haven't I? Now this circle has got a radius of 6, so its arc length, this length here, is half of the circumference of this circle. Now the circumference of a circle is pi times diameter. This diameter is 12, isn't it? Or it's 2 pi r, it's the other way of writing it. Anyway, but the circumference of this circle is going to be 12 pi. So half of that then is going to be the arc length of the semicircle. So 12 pi divided by 2 is 6 pi. Question 4. Circle the fraction that is equivalent to 4.625. Okay, I'm going to write this down then as a fraction. So let's say 4.625. That is equivalent to 4 and 625 1/1000ths then, isn't it? Okay. Or I could rewrite that as 4,625 1/1000ths. That's also a possibility. Okay, now both these numbers end in 5, so I should be able to divide them by 5 at the very least. So I think it's a matter of just now cancelling it down and see where I can get it to then. So 4,625 divided by 1,000. I know they're both divisible by 5. So what does that give me? It's going to give me 200 on the bottom. 5s into 4,625. When I divide by 5, I kind of double it and then divide by 10. That's the easiest way I find. So double in 4,625 takes me to 9,250, and then taking off a 0, it's going to give me 925. So 925 out of 200. Again, these both ending in 5s and 0s, so I think I can divide them both by 5 again. So 5s into 200, that's the easier bit. Let's do that. That's 40. 5s into 925. Again, I'm going to double it and then scratch that 0 off the end then. So double 925 is 1850, and then take the 0 off is 185. So 185 over 40. Right, how are we doing? Okay, now again, got 5s and 0s, so they're both divisible by 5. So 5s into 40 go 8 times, and again 185. Let's double that. That gives me 36370. Take off a 0. It's 37 over 8. So it's got to be that one there then. Question 5a. Write 0.00097 in standard form. Okay. So it's obviously going to have a negative exponent or power. Now the mantissa part is just the digits written as a number between 1 and 10, aren't they? So I'm going to take my 9 and 7 digits, and I'm going to put the decimal point somewhere so it ends up being a number between 1 and 10. So I'm going to put it here, 9.7. And then I need to multiply it by whatever power of 10 takes me back to the original number. So it's going to be negative because it's smaller than 1, and I've got 1, 2, 3, 4 zeros there. So however many zeros there are, that is the power that you're going to get there. Another way some people think about it is moving the decimal point. 1, 2, 3, 4 jumps to the right. That also gives you that 4 there. So either count the zeros, including the one in front of the decimal point. 1, 2, 3, 4 is going to be power to -4, or count the decimal place jumps. Either way, it's 9.7 times 10 to the -4. Right, what does part B say? Work out 3 times 10 to the 5 divided by 4 times 10 to the 3. Okay, so when you're doing multiplication or division with numbers in standard form, multiply like with like, divide like with like. So let's do the easy bit first. 10 to the 5 times divided by 10 to the 3. Got two numbers with the same base, so we just subtract the indices. So that is going to give me 10 to the power of 5 subtract 3, which is 2. And then 3 divided by 4, that's 3/4, and that's 0.75. So that's 0.75 times 10 to the 2. So that's 0.75 times 100 then, isn't it? 0.75 times 100, so that is 75. I think it's 75. Question 6. Anna plays a game with an ordinary fair dice. If she rolls 1, she wins. If she rolls 2 or 3, she loses. And if she rolls 4, 5 or 6, she rolls again. When she has to roll again, if she rolls an odd number, she wins. And if she rolls an even number, she loses. Complete the tree diagram for the 4 missing probabilities. Now, probability is defined to be successful outcomes divided by total outcomes, isn't it? Okay, so what is the probability that she rolls a 1 then? Well, how many successful outcomes there are? There are 1. There's 1 1 on a dice. Out of the total outcomes possible, that's 1 in 6. So the probability she gets a 1 is 1 in 6. Probability that she gets a 2 or 3, that's going to be 2 out of 6. And then probability she gets 4, 5, and 6 is going to be 3 out of 6. Okay, so when she rolls again, if she rolls an odd number, she wins. Well, there are 3 odd numbers, 1, 3, and 5. So the probability that it's going to be odd is 3 out of 6. And then the probability that she rolls an even number is also going to be 3 out of 6. Now, I know I can cancel some of these down, but often probability, it's easy to leave them as it is, and you don't get any extra credit anyway for doing so. So anyway, let's fill out our table now, our diagram. So we said that was going to be 1 out of 6 for a 1, or a 2 out of 6 for a 2 or a 3. 4, 5, and 6 is a half. It's already been given. And then my second row, I don't have to do a second row for those first 2. But if we do have to have a second row, it's 3 out of 6 here and 3 out of 6 here. Okay, is that it? Yeah. Oh no, there's more over the page. Is Anna more likely to win or lose? You must work out the probability that she wins. Okay. So winning then is either that she wins on her first roll by going down this route, that's a win, or if she rolls an odd number on her second roll, so if she goes this way, down here and then up here. Okay, so the probability of win then is going to be that outcome or that route through there. So I'm going to say probability of win is equal to the probability of getting a 1 on the first row plus the probability of getting a 4, 5, or 6 on the first row and odd on the second row, isn't it? Okay. So the probability of rolling a 1, that was just simply 1 out of 6, plus the probability of getting a 4, 5, or 6, that was 3 out of 6, wasn't it? And means times in probability, odd, so that was 3 out of 6 as well. So I've got 1 over 6 plus 3 over 6 times 3 over 6. So 3 over 6 times 3 over 6, that's going to be 9 over 36. Now I need to add 1 over 6 and 9 over 36. I need to kind of find a common denominator. Well, I can actually simplify 9 over 36 to, if I divide top and bottom by 3, I'm going to get 3 over 12. And if I double up 1 over 6, I'm going to get 2 over 12. So adding those two together then, I'm going to get 5 over 12. Okay, so the probability of win is 5 out of 12. So remember the question is Anna more likely to win or lose? Well, the probability that she loses is 1 minus the probability that she wins, isn't it? So that's going to be 1 minus 5 over 12, which is 7 over 12. Okay, so probability that she loses is greater than the probability then that she wins. Okay, just need to be careful in these sort of questions that you've actually stated what it is that they want you to do. Is she more likely to win or lose? So we've said more likely. Let's put it in words as well. Then come more likely to lose. Sorry. Okay. Question 7. 3 friends arrive at a party. Their arrival increases the number of people at the party by 20%. In total, how many people are now at the party? Okay. Now, percentage questions like this I normally do with a triangle, final, original, multiplier, and then I work out what I've got. Have I got the final? Have I got the original? Have I got the multiplier? Final is the value at the end. Original is the value at the beginning, and multiplier is the decimal version of the percentage that's been applied. Okay, so now this is a percentage increase. Okay, so the number at the party is going up by 20%. So 100% plus 20% is 120%, which is a multiplier of 1.2. Now, the original number of people at the party we don't know, actually. Let's call that X. And then the final number of the people at the party is going to be our original people at the party plus the 3 that arrived. So I'm going to get X and X plus 3 people at the party afterwards. So in total, how many people are there now at the party? I can use that to form an equation in X because I can say that my final percentage is equal to my original times my multiplier. Okay, so my final I decided was X plus 3, and my original was X, and my multiplier is 1.2. So I've got X plus 3 is equal to 1.2x, and haven't I? Okay. Now what can I do? So taking X away from both sides, I'm going to get 3 is equal to 0.2x. So then if I want X, I'm going to have to multiply both sides by 5 then, aren't I? Times by 5 times by 5. So I'm going to get X is equal to 15. So there were 15 people at the party, 3 people joined, making 18, and that is an increase of 20%. So if X is 15, then F final must be 15 plus 3, which is 18, then, isn't it? And that is the answer we're looking for. We're looking for the, in total, how many people are now at the party. So we want that F value. So the answer is 18 people. Question 8. Work out the value of 3 to the power 12 divided by 3 to the power 5, all divided by 3 to the power 2 times 3. Okay. Now I'm going to do the bits in the brackets here to start with, because brackets come first. So let's do that bit and that bit first, and then we'll work out what we've got after. So inside the brackets, 3 to the power 12 divided by 3 to the power 5. So I've got two numbers with the same base that I'm dividing, so I subtract the indices. So 12 subtract 5 is going to be 7. So that's 3 to the power 7 divided by the second bracket, 3 squared times 3. Two numbers with the same base that I'm multiplying, so I'm going to add the indices. 3 to the 2 times 3 to the 1 is going to be 3 to the 2 plus 1. It's 3 to the 3. Okay. Again, I've still got two numbers with the same base. I'm dividing this time, so I'm going to subtract the indices. 3 to the 7 divided by 3 to the 3 is going to be 3 to the power of 7. Subtract 3, which is 3 to the power 4. Okay, 3 to the power 4. Do we have to actually work out the value? What is 3 to the power 4? That's 3 times 3 times 3 times 3, which is 3, 9, 27. 3 lots of 27 is 81. Okay, so my answer is 81. Okay, done. Question 9. A shaded semicircle is inside a circle as shown. The radius of the circle is 10 centimeters and the diameter of the semicircle is 8 centimeters. How many times bigger is the unshaded area than the shaded area? Okay, so let's work out the shaded area first. Shaded. Okay, that's this bit here, isn't it? Now, the area of a circle is pi r squared. So a semicircle is going to be pi r squared over 2 then, isn't it? Okay, so in this case, r is half of d, the radius is half the diameter. So it's 4 squared, 16, divided by 2, 8. That's going to give you 8 pi. Now let's have a think about the unshaded area. Now it is a circle, so it's going to be pi r squared, where this time the radius is going to be 10. So r squared, 10 squared is 100. So that's 100 pi. But remember, the unshaded area is going to have the shaded area cut out of it then, isn't it? We want the area of the unshaded part, not the area of the circle. So we need to take off that pi r squared over 2 that we had earlier. In other words, we need to take out the 8 pi. And 100 pi take away 8 pi is 92 pi. Okay? So the unshaded area is going to be 92 pi and the shaded area is going to be 8 pi. How many times bigger? Number of times bigger is going to be the bigger one, 92 pi, divided by the smaller one, 82 pi. Now I left it in terms of pi because I can then just cancel those out. That pi cancels with that one, and then I just need to divide 8 by 92. Okay, so 8s into 80 go 10 times, so 11 8s are 88, so it's 11, remainder 4, 11 and 4 eighths, which is 11.5, isn't it, 11 and a half. Okay, so it is 11 and a half times bigger. Done. Question 10. The number of items n made in 1 hour by a machine is given by n equals 60 over t, where t is the time in minutes a machine takes to make one item, and the value of t changes for different types of item. On the grid below, draw the graph of n equals 60 over t for the values of t from 1 to 4. Okay, so let's just do a quick table of values then. For t equals 1, 2, 3, and 4. And the corresponding values of n. Okay, now note that t can't be 0 because then you'll have division by 0, which is a bit of a no-no. So let's start with t is equal to 1. N is equal to 60 divided by t. 60 divided by t is 60. If n is 2, then 60 divided by 2 is 30. We're halving each time, aren't we? So n is 3. N 60 divided by 3 is 20. And n is 4. 60 divided by 4 is 15. Okay, so then my points I'm going to plot. So at time 1, t is equal to 60. At time 2, t is equal to 30. At time 3, t is equal to 20. And at time 4, t is equal to 15. Okay, so I'm going to, what am I going to do with that? Am I going to join it up with a curve? On the grid below, draw a graph, so I suppose I do have to join them up with a curve. Okay, so it's going to be one of those graphs. It's a little bit like 1 over n, isn't it? It's going to be like the right-hand part of 1 over n. So my line is going to come down from infinity through those points, like that. I think I missed that first point. Let's try that again. So my line is going to come down from infinity through that point, through that point, through that point, through that point. Okay, so your axes are asymptotes here, aren't they? Okay, right, so part B says the machine takes 3 minutes 30 seconds to make one item. Use your graph to estimate the value of n. So 3 minutes 30 is halfway between 3 and 4. Let's get a ruler out. Oops, draw a line up from 3.5, which is going to be halfway between 3 and 4 to the line. Okay, and when we get to the line, I'm going to change direction. And we're going to go that way until we get to the y-axis. Okay. What's that value there then? Okay, counting little squares between 0 and 10. I've got 1, 2, 3, 4, 5 of those. So they must be going up in twos. 2, 4, 6, 8, 10. So that one there has got to be 10, 12, 14, 16, isn't it? So I'm going to estimate that the number of items is 16. N equals 16. Question 11. Ed and Faye share £330 in a ratio of 7 to 4. Ed gives Faye some of his money. Faye now has the same amount as Ed. How much does Ed give Faye? Okay, so we're going to be dividing £330 in the ratio of 7 to 4 to start with. So there's my £330. We're going to be dividing in the ratio of 7 to 4. So I'm going to take the ratio 7 to 4 first off. I'm going to add the two parts together to find out how many shares there are altogether. Ed's going to get 7 shares. Faye's going to get 4 shares. That makes 11 shares altogether. Now, taking my total amount, I'm going to divide it up and then divide that by the number of shares. 330 divided by 11. 11's into 33 go 3 times. So 11's into 330 going to go 30 times. So each share then is worth £30. So then we can take our ratio of 7 to 4 and we can scale it up by a factor of 30. So multiplying both these by 30, we'll get the amount that each of them gets. So 7 times 30 is 210, so Ed's going to get £210. And 4 times 30 is 120, so Faye is going to get £120. Okay, so that's how much they're going to get when they divide the ratio into 7 to 4. And then it says Ed gives Faye some of his money. Now Faye has as much as Ed does. Okay. Well, half of £330 is 165. So they're both going to end up with £165 then if they're going to have the same amount each. So what's the difference between 210 and 165? So I'm just going to write down 330 divided by 2 is 165. So 210 subtract 165 is how much then that Ed gives Faye. So 210 subtract 165, what's that then? It's 35.45, isn't it? So the answer is that Ed gives Faye £45. Why didn't they just split into the beginning, eh? Save all this problem. Anyway, let's move on. Question 12. The next term of a sequence is made by adding the previous two terms. Which of these sequences follows this rule? Okay, so the next term of a sequence is made by adding the previous two terms. That's a Fibonacci type sequence, isn't it? So which one of these is a Fibonacci type sequence? If I add negative 9 and 7, do I get 7? Yes, I do. If I add 2 and minus 7, do I get negative 5? Yes, I do. If I add negative 7 and negative 5, do I get 12? Yes, I do. So that seems to work. That one is. If I add minus 3 and 5, do I get 2? Yes, minus 2. Yes, no, I don't. I get positive 2, so that one isn't. If I add 0 and negative 3, what do I get? I get negative 3. If I add negative 3 and negative 3, what do I get? I get minus 6, not 0, so that isn't one. If I add minus 1 and minus 1, do I get minus 2? Yes, I do. If I add minus 2 and minus 3, do I get minus 3? Yes, I do. So if I add minus 1 and minus 2, do I get minus 3? Yes, I do. And if I add minus 2 and minus 3, do I get 1? No, I don't. Okay, so the one that is the Fibonacci sequence then is this one here. Question 13. The triangular cross-section of a prism is an isosceles right-angled triangle. The volume of the prism is 102 centimeters cubed. Use approximations to estimate the value of x. You must show your working. Okay, so we are told that the cross-section, which is this bit here, is an isosceles right-angled triangle. So that's those two sides are equal. We can already see that they're both equal to x, and there's a right angle in it. Okay. Now use approximations to estimate the value of x. Right. First off, what have we got? We've got a prism, and the volume of a prism is given by the formula cross-sectional area times its length. Now in this case the volume, the cross-section is an isosceles triangle, which we can work out the area of by multiplying half times its base, which is x, times its height, which is x squared, and then times that by the length. Okay. So basically we want to rearrange this for x, don't we, so we can work it out. So first off, multiplying both sides by 2, I'm going to cross multiply that up there, aren't I? And then dividing both sides by length, I can cross multiply that down there. I'm going to get x squared is equal to v times 2 divided by the length. And so then if I want the x itself, I want the root of that then, don't I? So I want the root of 2v divided by L. Okay, so what's that going to be equal to? So 2 times v, we're told that the volume is 102, divided by L, which is 8.14. Okay, so what I'm going to do now is I'm going to, and then square root. So what I'm going to do now is I'm going to round each one of those off to one significant figure, because I'm going to use approximations. So 2 times 102 to one significant figure is 100, divided by 8.14 to one significant figure is 8. So it's the square root of 2 times 100 divided by 8. Okay, so 2 times 100 is 200. 8s into 200 go 25 times, don't they? Okay, and then so square root in that, I'm going to get 5. So we're going to estimate that x is equal to 5. Question 14. Here is a quadrilateral which is not drawn to scale. Underneath we've got some more information about this quadrilateral. We're told that A is 90. So it's good to read through this stuff down here, because sometimes it isn't marked on the diagram. In this case it isn't. So A is 90. Means that that angle there is actually a right angle, and the A to B is equal to 5 to 3. A to B is equal to 5 to 3, but we already know that A is 90. So what do we have to multiply 5 by to get 90? 5 goes into 18 times, so if I times that by 18, got to do the same this side as well. So 3 lots of 18, well 3 lots of 20 is 60, take off 6 is 54, isn't it? So I make B then 54 degrees, so now I know that one as well. Let's mark that one in, 54 degrees. And I'm told that x to y is 1 to 3. Okay, now we don't know what x to y is at the moment, but we do know what they add up to between them, because all 4 angles add up to 360, then a plus b plus x plus y must be 360. But we know that a is 90, and we know that b now is 54. So I know that x plus y then is equal to, so my x plus y then is going to be 360 minus the 90, and then minus the 54. So 360 take away 90 is 270, take away 54 is 216. So I know that between them x plus y is 216, and I know that the ratio of x to y is 1 to 3. So if I divide 216 in the ratio of 1 to 3, then I should be able to find out what x and y are. So similar to that question we just did a while ago, 1 plus 3 is equal to 4. So if x is getting 1 share and y is getting 3 shares, there are 4 shares altogether. Divide 216 a number of what the angles add up to by that number of shares. 4's into 216. What's that then? 4's into 21 go 5 times, remainder 1, and 4's into 16 go 4 times. So that's 54. Okay, so that means that x to y, which is in the ratio of 1 to 3, if I times out both of those by 54, I should be able to see that x is 54 and y is 3 lots of 54. So 3 50s is 150 plus 3 4s is 12, so 162. Okay, so x is 54 and y is 162. Okay, so I'm just going to wrap that up by saying what each of these values is. So we found that a is 90, b is 54, x is 54, and y is 162. And if you look here, look, I can therefore say that b equals x. Okay, all done. Question 15. Here is some information about the test marks of 120 students. And I've got a frequency table here, and you can see that it's grouped. So I know the marks from 0 to 10, 10 to 20, 20 to 30, and so on. Okay, now the first question for 1 mark is to complete the cumulative frequency table. So the values for m less than 10 is just going to be those 20 there, isn't it? The values of m less than 20 is going to be those 20 plus the 28. So 20 plus 28 is 48. That's already been given. Less than 30 is going to be the 20 and 28 with the 40, which I can just get by adding 40 onto 48. So that makes 88. Then the next one I'm going to get by adding 20 to everything that came before. So 88 plus 20 is going to be 108. And then finally add on the 12, takes me to 120. It's always a good idea to just check that this number here at the end is the same as the number you were given to start with. And then you can be pretty confident that you've got it right. Right, what does part B says? Okay, so now we need to draw that information into a cumulative frequency graph. Now, when you're plotting cumulative frequency curves, you need to plot cumulative frequency against upper class bound. So 20 is going to go against 10, 48 is going to go back against 20, and so on. So let's plot those on. So hopefully the examiner's already provided us with the axes. We just need to plot the points straight on. As you can see, I've got marks along the bottom and cumulative frequency up the side. So the first cumulative frequency, which was 20, marks less than 10 was 20 people. So mark less than 10 was 20 people, is that point there. We can also plot an additional point, which is our lowest point on the graph. We can plot 0 against whatever this lower class bound is on our first graph. In this case, it's going to be 0, 0. So I'm going to plot an extra point here, 0, 0, and then one at 10, 20. The next one's going to be at 20, 48. 20, 48. Now I've got how many squares between 40 and 60? I've got 1, 2, 3, 4, 5 little squares between 40 and 60. So I've got 5 squares spanning 20 units. So each one of those little squares is going to be worth 4 then, isn't it? So it's going to be 40, 44, 48, 52, 56, 60. I think it's good just to count up like that, just to make sure you haven't made a mistake. So each one of those little squares is 4. So if I want to plot 48, it's going to be 2 squares up from 40, isn't it? So 20 is going to be here at 48. Right, what's the next value? M is 38 against 88. So 30 against, well, there's 80, and 2 more squares up. It's going to be 88 then, same as last time. And then finally, oh no, I've got 2 more. M is 40 against 108. 40 against 108, so 2 squares above 100. and then 50 was at 120, wasn't it? Okay, so you should get this distinctive S-shaped curve when you draw a cumulative frequency curve. It always starts low and ends high. Just go join it up with a nice smooth curve. Try and go through the center of each of the points that you have marked. Okay. What you don't want to do is have double lines. Okay, that will get you marked down. You shouldn't have double lines on it. And you don't want to miss the points entirely. You need to go skew at each point and not have kind of multiple lines. If you drew more than one line, just make sure one of them is rubbed out nicely. Okay, so I think we've drawn the graph nicely there. What's next? Part C says students who scored 15 marks or fewer take another test. Use your graph to estimate how many students took another test. Well, 15 marks. So 15 marks is here. I'm going to put the ruler on 15. And I'm going to draw up to the curve. And I'm going to change direction. And I'm going to draw across to the axes. What's that then? So that there then is the number of people then who got 15 or fewer marks. Oops, come back. So we said each one of these little squares is worth 4, so I make that 20, 24, 28, 32, halfway between 32 and 36. So I'm going to read that as 34. I'm going to go for 34. Okay, now you'll get a little bit of leeway, you know, anything between like 33 and 35 I think would be acceptable there. Okay, let's move on. Question 16. Simplify fully 4x minus 8x squared all over 12x minus 6. Okay, let's have a look at the top line first off. I've got 4x minus 8x squared. What's common to those two? Well, 4 and 8 have both got a 4 in them. And x and x squared have both got an x in them, so I'm going to take out 4x. Inside the brackets then, 4x times what is 4x? 4x times 1 is, and 4x times what is 8x squared? 4x times 2x is 8x squared, so I'm going to get that. Okay, what about on the bottom? So here I've got 12x and 6, so what's common to 12x and 6? 6 is, so I'm going to factorize out a 6. What's left? So 6 times 2x and 6 times 1 will give me 12x minus 6. Okay, so done pretty well so far. I haven't managed to simplify it yet though, just rewritten it in factor form. Can we cancel anything down top and bottom? Okay, well we've got 4 and 6 here, so we can divide both of those by 2, which should give me 2 and 3, won't it? Just like we would with a fraction. But we've got this 1 minus 2x here, which is quite similar to what's beneath it, but not quite, is it? What we can do is we can factorize minus 1 out of both the top terms, and that will have the effect of flipping those two terms around. So I'm left with 2. Oops. So I've still got 2x on the outside of the bracket and 3 underneath. But if I factorize minus 1 out of 1 minus 2x, minus 1 times 1 would be minus 1, and minus 1 times 2x would be positive 2x. So like I say, I have the effect of flipping these two terms around. So I'm going to get, rather than 1 minus 2x, I'm going to get 2x minus 1. And then that will match up with my 2x minus 1 I have on the bottom. And then I can cancel that with that. And it will just leave me with that little bit at the front, minus 2x over 3, which is about as simple as you can get, really, isn't it? Okay, so we've simplified fully. Question 17. Toby is forming and solving equations. Now we're told that the product of half of a number and 3 more than the number is the same as the square of the number. Toby uses y to represent the number. Write an equation that Toby could form. Okay, so the product of half of a number and 3 more than the number is the same as the square of the number. So product in maths means multiplied. So we're going to have two things multiplied together. So that's that part there. So then we've got half of a number. Well, if y is our number, then half of the number is going to be y over 2. So that's that part. And 3 more than the number. Well, the number is y, and 3 more than y is y plus 3. So we're going to get y plus 3. So that's that part. Is the same as the square of the number. Is the same as, in maths means equal to, equals. And then finally, I'm running out of nice colors. Okay, let's go for pink. The square of the number. So my number is y, so the square of y is going to be y squared. Okay, so that's that bit there. Okay, so y over 2 times y plus 3 is equal to y squared. So I'm just going to rewrite that as y squared equals y plus 3 over 2. Okay, lovely. Right, part B says Toby forms another equation and it's got x is equal to 9 over 8x. He wants to work out the value of x. Here is his working. So he's got x equals 9 over 8x. So then he's cross multiplied the 8x up here to give him 8x squared is equal to 9. Yeah, that's all good. And then he said that 8x must be 3 or 8x is minus 3. Okay, yeah, so square root in both sides. Okay, not sure you can do that, but I see what you're doing. And then x equals 3/8 and x equals minus 3/8. Oh, what error has he made in his working? It's this bit here where he's gone from here to here. So his square root in both sides, and he's saying, well, the square root of 8x squared is 8x, and the square root of 9 is plus or minus 3. But that doesn't work, because where he's got 8x squared is equal to 9, if you square root both sides, you're going to get root 8x is equal to plus or minus 3. Okay, so it isn't going to be quite what he wants. So he's written 8x, but it's actually root 8x. You have to root both bits. Okay, so that's where he went wrong. Question 18. Here is an identity. X squared minus y squared is identical to x plus y, x minus y. Now you should be very familiar with this identity. It's what we call the difference of two squares. I've got two squares that I'm subtracting or finding the difference of, and we're told that that's x plus y, x minus y. Okay, so use the identity to work out the value of 193 squared minus 7 squared. You must show your working. Okay, so what we're going to do is we're going to take 193 squared minus 7 squared, and rather than working out 193 squared, this is a non-calculator paper, isn't it? It's going to be tough. I'm going to use my identity instead. So if I've got two things, one thing squared minus the other thing squared, that's the same as the thing plus the thing, other thing multiplied the thing minus the other thing. In other words, 193 plus 7 times by 193 subtract 7. Okay, so 193 plus 7 is 200, and 193 subtract 7 is 186. Okay, so then we need to multiply these two things together. So multiplying 186 by 2 and adding 2 zeros on the end should do the job, shouldn't it? So what's double 186? Double 18 is 36. That'll be 360 plus 2 6s, 372. So 372 plus my 2 extra zeros. So 37,200. Okay, part B says factorize 100a squared minus 81b squared. Okay, So we know from the difference of two squareds that x squared minus y squared is equal to x plus y, x minus y. Okay, now here we've got two things that have been squared. What are they? So let's take the square root of 100a squared. The square root of 100a squared. The square root of 100 is 10, and the square root of a squared is a. So that is 10a. And the square root of 81b squared, square root of 81 is 9, and the square root of b squared is b. So I'm going to get 10a plus 9b and 10a minus 9b, like that. Question 19, circle the fraction that is equivalent to 0.1 reoccurring. Okay, so there's a little trick for converting recurring decimals back into fractions. Let's say x is equal to our recurring decimal, which is 0.11111, and so on, infinite number of ones. Now if I multiply that by 10, I'm going to get 10x is equal to 1.11111111, going on for infinity. Now if I do 10x take away x, so I'm going to subtract but uphill, if you see what I mean. So 10x subtract x, that's going to leave me with 9x on the left. And if I subtract 1.111111 by 0.111111, then these bits are going to cancel each other out, and it's just going to leave me with 1 subtract 0, which is 1. So 9x is 1, so x then, cross multiplying that 9, is going to be 1 over 9. So it's that one there, 1/9. Question 20. A, B, and C are points on a circle. CD is a tangent. And underneath the question it says, assume that the triangle ABC is isosceles with AC equal to BC. Prove that AB is parallel to DC. Okay, so assume that triangle ABC is isosceles with AC equal to BC. Well, AC is that length there, and BC is this length here, isn't it? Okay. Now, right, come back to the diagram. If CD is a tangent, then we can use the alternate segment theorem to state that that angle there, the angle between a tangent and the chord join at the point of contact, is equal to the alternate angle. So the angle drawn in the alternate segment, that one there. So this angle and this angle need to be equal to each other. Plus, of course, in triangle ABC, if it's an isosceles triangle, then we can say that the base angles are equal. So then this angle up here must also be equal. Okay, so we've got 3 equal angles now. Okay, now if CD and BC are parallel, then this line here, the line AC, has got to be a transversal, then a line crossing 2 parallel lines, and this angle in here and this angle over here should be alternate and therefore equal. Okay, so if you've got 2 pairs of parallel lines and a transversal, then these 2 angles, the alternate angles, are equal. Another way of saying that is, if these 2 alternate angles are equal, then the lines must be parallel because you've got alternate angles. So it works both ways. Parallel lines implies alternate angles also imply parallel lines. Okay, so we need to write that up. So we said using alternate segment theorem, we showed that ACD, angle ACD, was equal to angle ABC. Okay? And then because base angles in A isosceles triangle are equal, and that means that angle ABC is equal to angle BAC. So BAC is equal to angle ABC, which is also equal to ACD. They're all three of them are equal to each other. And then we can say if AB is parallel to CD, then AC is a transversal and angle BAC is alternate to AB to the other one. What was that? ACD. And therefore BAC should be equal to ACD. Hence AB is parallel to DC. Okay. 20b. In fact, triangle ABC is equilateral. Tick the two boxes for the statements that must be correct. AB is parallel to DC, AC bisects angle BCD, or AC bisects angle BAD. Let's go back to our diagram and add in the extra information. So if it's actually not an isosceles triangle, it's an equilateral triangle, then also that length is equal, and also that angle is equal. They're all equal to 60, aren't they? 60, 60, 60, 60. Okay, so now what do we know? Let's just check each one of these in turns. Is is line AB parallel to DC? Is that true? Is AB parallel to DC? Yeah, that's not going to change that, is it? That's what we just shown before. So angle AB is still parallel to DC. Yes, that's still true. Does AC bisect angle BCD? Does AC bisect angle BCD? Oops. Where's AC? AC is the green angle. Does it bisect angle BCD? Well, if it bisects it, it cuts it exactly in half, and it does, doesn't it? Because that angle is 60 and that angle is 60, so therefore that is true. So that is also true. Does AC bisect angle BAD? BAD. Does AC bisect BAD? Is that also true on this side? Well, we don't know, do we? Because we don't know this angle here. Is there any reason to suspect that angle is 60 as well? We've got no reason to think that is the case. So I say that one is not true, or not necessarily true anyway. So I'm happy with our two choices then. AC, that is not the case. The other two are true, and we have now ticked two boxes of statements that must be correct. Okay, happy with those. Let's move on. Question 21. Solve the simultaneous equations 2x plus 3y is equal to 5p and y is equal to 2x plus p, where p is a constant. Give your answer in terms of p in their simplest form. Okay, so I've got two equations. They're both linear equations. I think the easiest way is going to be solving them by elimination. But first off, we need to make sure they are kind of both written in a compatible format for elimination. To do that, I'm just going to take this 2x, the second equation, and move it over to the other side of the equation. So my first equation, 2x plus 3y is equal to 5p. That can stay as it is. And the second one I'm going to rewrite by moving that 2x to the other side. So if I change sides, I'm going to change its sign. It's going to be minus 2x plus y is equal to p. Okay, so now you'll see I've got a 2x here and a minus 2x here. So if I take these two equations and I add them together, then those two things are going to cancel each other out, aren't they? Because 2x plus minus 2x is nothing, so they're going to cancel. If I add the other things, 3y and y gives me 4y, and 5p plus p is 6p. So dividing both sides by 4 gives me y is equal to 6p over 4, which is the same thing as 3p over 2. Okay, so that's my y then, and that's in terms of p in the lowest possible form. Next thing we need to do is to find x. So if we use maybe the second equation, doesn't matter which one, if I use y is equal to 2x plus p, subbing in what I know now for p, for y, so 3p over 2 is equal to 2x plus p. Taking p from both sides, 3p over 2 is 1.5p, isn't it? So if I take p away, it's going to leave me with half p. So p over 2 is equal to 2x, and then dividing both sides by 2, I'm going to get x is p over 4. So x is p over 4 is one solution, and the other one is 3p over 2. Question 22. A, B, C, and ACD are triangles, and k is a constant. We've got a diagram here, and I can see I've got 3 vectors written on it. Part A says, show that the vector C to D is equal to 6 lots of vector A plus 4.5 lots of vector B. Okay, well, C to D is this line here, isn't it? We need to go from there to there. Now, we don't have any vectors marked along that length, but we do have one here and one here. So we can get from C to D by going via A. So that's what we need to do. So the vector, so we can say that the vector C to D is equal to the vector C to A plus the vector A to D. Now we know that the vector C to A, well, it's kind of going against that arrow, isn't it? If you look at C to A to C is 3b because the arrow is going this way. We're going against the arrow, so it's going to be minus 3b. So that's equal to negative 3b plus vector A to D, which is 6a plus 7.5b. Okay, once we've written it like that, we can just collect together like terms, very much like we do with algebra. So we've got one term in vector A, and we've got two terms in vector B. So that's going to give me 6a plus 7.5b subtract 3b is 4.5b as requested. Okay, so 6a plus 4.5b, we've shown it. 22b says BCD is a straight line. Work out the value of k. You must show your work in. Let's go have a look at the diagram again. So BCD is a straight line. Work out the value of k. Okay, well k is up here. Look, it's on this stretch here. Now we can, and we're told that BCD is a straight line. Now we've already found the vector C to D. Now we can find the vector B to C using the vector KA plus my 3b there. And because B, C, D are 3 collinear points, or they're in a straight line, then the vector C to D is going to be some multiple of the vector BC, isn't it? Okay, because they're both going in the same direction. So we're going to use the fact that vector C to D is some scalar multiple of the vector B to C. Okay, where m is some number. Okay, doesn't really matter what that is at the moment. That's what we're going to show. We're going to show that these two vectors are going to be a scalar multiple of each other, and then hopefully we can work out what k is by comparing it with BC. Okay, so let's do that then. So C to D we've already found. So let's find B to C first. So B to C we can find by going via A like we did last time. So B to A plus A to C. So B to A is that vector KA, and A to C is that vector 3B. So we're going with the arrows in both directions. So it's just simply KA plus 3B. Okay. Now we know that vector CD is some multiple of vector BC because they're 3 collinear points. In other words, C to D, which we found earlier, 6A plus 4.5B, that's the vector we found for CD earlier, is equal to some scalar multiple of our new vector that we found, KA plus 3B. Okay. Now we can compare like with like. So we've got 4.5b is equal to, well, we can multiply this out if we want to. That might be easier to see. Let's just multiply that bit out. Equals mk lots of a plus 3m lots of b. Okay, so then we can directly compare these then. So 4.5b is equal to 3mb. So comparing the b parts, 3m then must be 4.5b. So what does that make m? 3 times what is 4.5? That makes m 1.5 then, doesn't it? If I times 3 by 1.5, I'll get 4.5. Okay, so then m must be 3 over 2, 1.5. And if m is 3.5, then I can say that 6, my 6 from 6a must be equal to m lots of k. Okay, so 6 is going to be 3/2 of k. So 6 is equal to 3 over 2 lots of k. So rearranging that for k, cross multiplying, timesing by 2, dividing by 3, I'm going to get 12 divided by 3, I know, which is 4. K is equal to 4. Okay. That comes about by the fact that if two vectors are equal, then their A parts must be equal and their B parts must be equal. So that's what I did. I kind of separated them out and compared them. Okay, but we come up with the answer K is 4. Question 23, we've got some fun with indices here. Simplify 8 to the power of 4 divided by 32 to the power of 2/5. Give your answer in the form 2 to the power of m, where m is an integer. Okay, so we've got a fairly horrendous looking calculation here. So 8 to the 4 divided by, I'm just going to rewrite it like a quotient, 32 to the power of 2 over 5. Now 8 and 32 are both powers of 2, aren't they? So 8 is 2 cubed. So I'm going to rewrite 8 as 2 to the power of 3. And I'm going to rewrite 32. 2, 4, 8, 16, 32. That's 5, isn't it? 2 to the power of 5. 2 to the power of 5 to the power of 2/5. Okay? Right, so on the top, I've got a index of an index. So 2 to the power of 3 raised to the power of 4. So I have to multiply these two indices together, don't we? So that's going to be 2 to the power of 12 divided by, and the same thing here, I'm going to have to multiply my 5 with my 2/5. 5 times 2/5, that's very easy. That's just 2, isn't it? The 5s cancel each other. So that's 2 squared. And then I've got two numbers with the same base, so I can subtract the indices. So 12 subtract 2 is going to be 2 to the power of 10. 2 to the power of 10. So give you the answer in the form 2 to the power n, where n is an integer. We have. 2 to the power 10. Okay, good. Question 24. F of x equals sine of x minus 90. Circle your value of f of 0. Okay, so this is defined in function notation. So f of 0, then you're replacing the x's in the expression with 0. So f of 0 is going to be the sine of 0 subtract 90. In other words, it's going to be sine of negative 90. Okay, right, do you remember what the sine curve looks like? Okay, if I draw a sine curve, it starts at 0, doesn't it? It kind of oscillates like this. Okay, and you should remember that the period of that is 360 degrees. It takes 360 degrees to go through a full oscillation, which means that's 180 and that is 90, and so on. So that's 360. And so in the middle is 270. Not that we need to know that. What we need to know is what the value of sine to the minus 90 is. Okay, so if it goes like that and it oscillates, it's also going to repeat on the opposite side of the equal sign. So it's also going to do that. It's going to kind of work backwards that way as well. So if the distance from there to there is 180, then the distance from there to there is also 180. So that number there is minus 180. And then halfway in between is going to be minus 90 then, isn't it? Okay, which is the lowest point on this sine curve. Now, sine oscillates between 1 and minus 1. So I can see that the sine of negative 90 is going to be minus 1. So I'm going to go for that one there. Question 25. The point P with coordinates 4, 8 is a point on a circle center O, origin. The tangent at P intersects the axes at points A and B. Okay, so it's always good to read this text at the top just in case it's got any extra info in it, but I don't think it does here. We've got the point P, it's already marked, and we're told that the tangent cuts A and B, okay, which is already on the diagram. Okay, so what's the question? Show that the gradient of a tangent is minus a half. Okay, so we need to find the gradient of this line that's heading off down here. Okay, now at the moment we only have one bit of information about that. That's the point P that lies on the line. In order to find a gradient, we need to know two pieces of information. We need to know a second point on the line, which we don't have at the moment. Okay, but we do know that AB is a tangent, which means if I draw this this line on here, it will cut. Well, it will be at right angles to the tangent, won't it? Because that's a radius. So if I can find the gradient of the radius, then I should be able to find the gradient of the tangent because it's perpendicular. Okay, so that's what we're going to do. So the point O is the point 0, 0, and the point P is the point 4, 8. So we can find the gradient of that line. Let's call that M1. So gradient of OP, which is M1, is going to be y2 minus y1 over x2 minus x1, isn't it? Okay, that's the formula for finding a gradient. So I take my two y values and take them away from each other. So the y values are 8 and 0. So 8 subtract 0 divided by my x values, which is 4 subtract 0. 8 divided by 4, which is equal to 2. Okay, so the gradient M1 is 2. We know that OP is perpendicular to PT. What are they calling it? Okay, let's call it PA. So M2 is going to be minus 1 over M1, which is minus a half. Okay, so when you've got two lines that are perpendicular, their gradients are the negative reciprocals of each other. So 2 and minus 1/2 are two negative reciprocals, aren't they? Okay, so let's move on. 25b, work out the length of AB. Give your answer in the form of a root 5, where a is an integer. Okay, so coming back to our diagram, we still don't know any other information about this line other than the gradient now. We know that the gradient M2 is minus a half, okay? But we do have the gradient of a line and the point it goes through, 4, 8, so we should be able to find its equation. And once we found its equation, we should be able to find A and B, because we'll just have to sub in y is equal to 0 and x is equal to 0 to find those two intercepts. So let's do that then. Okay, so let's find the equation of the line first. So we know that our gradient M2 is minus a half, and it passes through 4, 8. So the equation of our line is going to be of the form y is equal to mx plus c, where m is minus a half. So minus a half of x plus c. Okay, so we know that x equals 4 when y is equal to 8, because we've got this point on the line. So let's sub that in. So 8 is equal to minus a half lots of 4 plus c. Minus a half lots of 4 is minus 2. Oops, what happened there? So 8 equals minus 2 plus c. So taking my minus c, taking over the equal sign, change sides, it's going to become 10, isn't it? So c is equal to 10. So therefore, equation is y is equal to minus a half x plus 10. Okay, so let's find the coordinates of AB first, and then we can find its length. So point A, so at A, which is the bottom one, wasn't it? Yeah, the bottom one is when y is equal to 0. It's the x-intercept. So when at A, y is equal to 0, so we've got 0 equals minus a half of x plus 10. So what does that mean? That means half x equals 10, so x is equal to 20 then, doesn't it? X is 20. Okay, and then at B, x is 0 because it's the y-intercept. So then y is going to be minus a half lots of 0 plus 10, which means y is going to be equal to 10. Okay, so coming back to our diagram, so we now know that that's the point 20, 0, and we know that that point up there is the point 0, 10. Okay, so taking out the triangle BOA, let's just draw it here because it's getting a bit crowded up here. BOA, we know that's a right angled triangle where OB is 10 because we know the coordinates of B, and OA is 20 because we know the coordinates of A. So then the length of this line then we can find out using Pythagoras theorem. So we can use c squared equals a squared plus b squared, can't we? Okay, so using Pythagoras theorem, c squared equals a squared plus b squared. We know that 10 squared plus 20 squared, all square rooted, is going to be c then, isn't it? Okay, so then reaching for a well, I can't reach for a calculator because it's a non-calculator paper. So let's hopefully we can do this. Oh no, we can leave it as a root, can't we? So that's equal to 10 squared is 100, 20 squared is 400. Add them together is root 500 then, isn't it? Okay, so c, the length is root 500. Oh, it wants it to write in the form a root 5, so we just need to cancel that down now. Which is equal to, well, we can say that's 100 times 5, can't we? And then we can break that up into 10 root 5. Okay, so c is equal to 10 root 5. That's our final answer then. Question 26. The turning point of a graph y is equal to x plus a all squared plus b has x coordinate minus 2. And we're told that 3, 1 is another point on the graph. Work out the y coordinate of the turning point. Okay, so this equation has been given in completed square form, hasn't it? Or partially complete square form, because we don't know what a and b is. But we've been given a bit of the information here. Now, if I've got a graph or an equation given in completed square form like this, then this equation is at its minimum value when this bit in the bracket is equal to 0. And if the x coordinate is minus 2 at that point, then a must be 2. So when I've got minus 2 plus 2, I get 0. Okay, so we know that it's of the form y is equal to x plus 2 all squared plus b. So a is equal to 2, isn't it? That's what we discovered. So x plus 2 all squared plus b is going to be our turning point. So when x is minus 2 plus 2 is 0, that's going to be its minimum value. Okay, now we know that 3, 1 is another point on the line. So at 3, 1, that means if I sub in 3 and 1 for y and x into this equation, then the only thing unknown there is going to be b then, isn't it? So we can find b. So at 3, 1, 1 is going to be equal to 3 plus 2 all squared plus b. So just replacing y with 1 and 3 with x. Okay, so then inside the bracket there I've got 3 plus 2, which is 5, and 5 squared is 25. So I've got 1 is equal to 25 plus b, and that makes b then equal to minus, taking 25 away from both sides, minus 24 then, isn't it? So I've got a is 2 and b is minus 24. So b, the b coordinate in the completed square form, that's going to be the y value of the turning point. So therefore, turning point, not turning point, turning point is minus 2 minus 24, and the y coordinate then, therefore y coordinate is minus 24. Don't know why that looked a bit so weird. Let's just write that again, minus 24. Okay, y coordinate is minus 24 and the turning point is at minus 2 minus 24. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 27. Angle x is acute. Cos x equals sine 60 times tan 30. Work out the size of angle x. You must show your working. Okay, now in order to answer this question, you need to know your exact values for trigonometry. So you need to know the sine, cosine and tangent of 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. If you know all that, then this problem is no problem. So cos x equals sine 60 times tan 30. So we know from our table of values that we have memorized that sine 60 is root 3 over 2. And tan 30 is root 3 over 3. So if you have a look at that, got a fraction, two fractions multiplied together. So multiply top with top, bottom with bottom. So root 3 times root 3 is just 3. And 2 times 3 is 6. So we get 3 over 6, which is 1 over 2, or half. So what angle has a cosine of a half? Now again, if you know all your exact values, you know that x then must be equal to 60 degrees because cos 60 equals a half. Okay? Now the only way you're going to answer this question is if you know those values for sine, cosine and tangent. So if you haven't learned them yet, write them in the table, look at them, write out the table, look at them again, just check that you got it right and keep doing that until you can memorize them all or you know them all. You need to know them. Okay. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.